same video. So in 9.2, we will determine if an ordered triple is a solution to the system. So now we're identifying a system of solution in 3 variables. And as you can see, we have a system here, and this solution must satisfy all 3 equations in the system. So we have equation 1, 2, and 3. So let's just jump right in. With equation 1, we have 0 minus 4 times negative 2 plus 5 equals 13. And as you can see, that works for equation 1. Let's try equation 2. We have 3 times 0 plus a negative 2 minus 5. And we have, that should be a negative 7. And then we have, and this, yeah, negative 2 minus 5. I'll just keep that. It's not multiplication. So there we have a negative 7 equals negative 7. So that works. So now we just have to check equation 3. So 2 times 0 plus 3 times negative 2 plus 5 equals negative 1. And as you can see, we have negative 6 plus 5. And sure enough, negative 1 equals negative 1. Therefore, yes, it is a solution. Okay. Okay. Now, how are we going to solve systems of linear equations in 3 variables? Well, what we're going to do is we are going to first choose a pair of equations and eliminate one of the variables of this pair. Then we're going to choose, and here we go, this is a different pair of equations, and we're going to eliminate the same variable, okay? Let's start with that, okay? So we're going to have equation 1, 2, and 3. So let's just go ahead and choose, and we could go ahead and write these as A, B, C. So when we write multiplication, this might be nicer. So we have equation A, B, and C. So let's just choose equation A and B. And if we look at equation A and B, we just have to multiply equation B by a negative 1, and we could eliminate Z. And we could also eliminate Z from, and you could just pick either. Let's just decide in the beginning. We're going to eliminate Z. There's many that you could, but we just decide we're going to eliminate Z from A and B, okay? So in order to eliminate Z, we're going to need to multiply equation B by a negative 1, okay? So we're going to have equation A, and then we're going to have negative 1 times equation B. And so when we add these up, as you can see, we eliminated Z, and we have negative x plus 2y equals 3. Now we're going to hang on to this because now we're going to eliminate Z from B and c. And how are we going to eliminate z? We're going to have to multiply equation b by 2. Okay, so let me just move this over to the right. So multiplying equation b by 2, we have 4x minus 2y minus 2z and 4x minus 2y minus 2z equals negative 14, and we'll just keep z. X plus 6y plus 2z equals negative 1. Okay, and as you can see, we eliminated z. So we have 5x plus 4y equals negative 15. So now what are we going to do? Now it says you should now have two equations in two variables. And we're going to be solving just like we did in the previous section. We can use substitution or addition. I think the addition method is going to be the best for us. Let's see what variable we could eliminate. So let's look closely at this. And if we have equation negative x plus 2y equals 3, 5x plus 4y equals a negative 15, as you can see, we could eliminate y if we multiplied the first equation by a negative 2. So let's go ahead and see what we have. So we have a 2x minus 4y equals a negative 6, and we still have this second equation, and as you can see, we eliminated y. And now we actually have that 7x is equal to negative 21, and x is equal to negative 3. We have our first value. Okay, so now what does it say? Now we have the value of the variables found above, and now we can go into any of the three original equations. Okay, so I can go use this x equal to negative 3, and I'll just use this first equation. And we come up with y. I did a really bad job here. This should be a positive 9, a positive 3. Goodness. And then, as you can see, if we subtract 3 from both sides, we get 2y equal to 0 and y equal to 0. So now we will go into any of the three original equations. Let's just use A. Okay, so going into original equation A, we have x plus y minus z. Let's write that out. And I think that was a negative 4. Let's go look. Yes. So we have negative 3 plus 0 minus z equals negative 4. We have a negative c equals a negative 1. So z is equal to 1. Okay, so guess what? We have our ordered triple that is the solution. So our solution is x, y, and z. Okay, let's take a look at number 2. And as you can see in number 2, we again have 3 equations. Why don't we just call them A, B, C? And as you can see, we do need to clear the fractions in equation A, and then we also need to rearrange some terms. So let's go ahead and multiply A times 2, and we'll rewrite B and C. So we have 2x minus y, and actually I think I should multiply by 6 to clear both of those fractions. So we have 6x minus 3y plus 2z equals 30. And the second equation is just fine. And the third equation, we'll have to add 3y. And as you can see, now we have 0 on the left-hand side. So using equation A and B, let's see what we're going to eliminate. We might as well just go ahead and eliminate z. So now, in order to eliminate z, we're going to, I guess I'll just move that over here. We're going to use equation A, and in order to eliminate z, we'll have to have 2 times b. So we'll just rewrite A and 2 times b. And as you can see, we have 8x minus 5y equals 28. Now we want to hold on to that because we now have to choose 2 more equations, just like we did here to the right, and eliminate that same variable, okay? So let me just move this down a little bit. And I could even move this eliminate z over. And really making a mess of all this, aren't I? But it's okay. Okay, so we've eliminated z from equations A and B, and now let's just choose, it doesn't really matter, let's choose B and C. And now it looks like we don't have to adjust these or multiply by any constants, because if we just add these 2 equations together, we will eliminate z. So we have 7x plus 2y equals -1. So now we will use both of these equations. We will take this equation and this equation. So we have 8x minus 5y equals 28, and 7x plus 2y equals -1. And as you can see, we could multiply this equation by 2 and this equation by 5. And it looks like we could eliminate y. So let's see. So we have 16x minus 10y equals 56. And then 35x plus 10y equals a negative 5. And we have eliminated y. So now we have 51x equals 51. So we have x is equal to 1. We have our first variable. Now I can go back into either one of these equations above with x equal to 1. So we could just go ahead and use the equation B with this one, and we have x minus y minus z equals a negative 1. So 1 minus y minus z equals, and we had, whoops, we probably can't do that yet because we need to plug 1 into one of these equations here, x equal to 1. So we'll just go ahead and go into this second equation, and we have 8x minus 5y equals 28, and we have to now solve for y before we can go back into one of the original equations. So now we have x equal to 1 and y equal to 4. So now we will go back into this original equation. So equation B. And equation B was x minus y minus z is equal to negative 1. I am definitely running out of room here. Let's see if I can raise that up and maybe make that a little bit smaller. And here we have 1 minus a negative 4. And then we have minus z equals negative 1. And we have z equal to 6. Okay, so now, thinking I could come over here. I better not do that. There we go. And now I can move this over. And then I can move this up. There we go. And so our solution is 1, negative 4, 6. Okay, let's look at number 3. And in number 3, we'll go ahead and have equations A, B, C again. And as you can see, we can eliminate Z right away with B and C. That should say plus. And so now we have 3x plus y equals 33. So now that was equation B and C. So now we could use A and our new equation. So since A doesn't have a Z in it, we now could use A with our new equation that we could call D, and here we could multiply D by -1, and I could put that in front. And I probably need to wait until the next line. Let's do that on the next line. So here we have X plus Y equals 19, and we're going to have a -1 times D. And here we'll have a -3x, whoops, minus Y equals a -33. And now you can see that we've eliminated Y. So we have -2x equals -14. So X is equal to 7. So now we could actually go back into equation B with X equal to 7. So we have 2 times 7 minus Z equals 4. And we have Z is equal to 10. And now we can go into equation B. We have Z equal to 10. And now we could go into pretty much any equation that you'd like. A is awful nice. If we have X equal to 7, we could find Y. We could do that. Or let's just go back into our original C. Let's just try that. So we have X equal to 7. We have Z equal to 10, and let's go back into our original C. But again, there's other equations you can go into. So we have 7 plus Y plus 10 equals 29. And as you can see, Y is equal to 12. So our solution is 7, 12, 10. Okay, let's look at number 4. So in number 4, as you can see, we have some cleaning up to do. So let's go ahead and clean these up first. So here we'll call this equation A, and we'll have -2x. Well, we're going to have to move that to the other side. So we have 2x plus Y minus 3z equals -3. And for B, we'll have to distribute that 2. So we'll have 4x plus 2y minus 6z equals -6. And for equation C, we'll just rearrange these terms. So there you have it. So now as you can see, if we look at equation A and B, and we multiply A by a -2, and we add that to equation B. So let's try that. So we have a negative 4x minus 2y plus 6z equals 6. And then we have 4x plus 2y minus 6z equals a negative 6. What happens? We get 0 equal to 0. This is a true statement. So here we have dependent system. There are infinitely many solutions. Now, how are we going to write these solutions, or the solution? So for us to find the general solution, we have to write the general solution in terms of any variable. Let's choose to write it in terms of x. Okay? You can choose any variable, but we want to write it in terms of x. So right now, we have x is x, okay? So we're going to try to eliminate variable y first. So we're going to eliminate variable y first. And we could do that through equations A and C. We could do that. And so we could do that by multiplying A by negative 2 and adding that to C. So we would have a negative 4x minus 2y plus 6z. I'm going to have to write this a little bit neater. So we have negative 2 times A. We have already written here. We already found that. And then now we have C is 3x minus 2y plus 4z equals 1. I think this was supposed to be a plus 2y. And we're just going to multiply this by 2. So I'm going to rewrite this. So multiplying A by 2, we have 4x plus 2y minus 6z equals a negative 6. Now you can see that we've eliminated y. So we have 7x minus 2z equals negative 5. So we're going to solve this for z. So we have 7 halves x plus 5 halves x. And let's just go ahead and write this as 7x plus 5 all over 2, okay? Bring that up. Okay. And now we have an expression for z, okay? So now all we need is an expression for y. And if you look at our original equations, we could use A and C again, and let's see what we would have. We would have, in A, we would multiply A times 4 to eliminate z. And in c, we would multiply by 3. So multiplying those out, we get 8x plus 4y minus 12z equals negative 12. And then we have 9x minus 6y plus 12z equals 3. And there we have eliminated z, and we can solve for y in terms of x. And so we're solving for y in terms of x. And we could just divide 17 halves x plus 9 halves. And now we could write 17x plus 9 all over 2. So we finally have this expression for our solutions, and it looks like this. X, 17x plus 9 divided by 2, 7x plus 5 divided by 2, and so we would have the set of all those values such that x is a real number. Again, it's a little bit tight here where I've written this. But we're able to see how to come up with that expression. Okay. Okay. Looking at number 5, we have a system of 3 equations, and we're going to go ahead and write these as ABC. And we don't have any rearranging to do, and we'll begin with A and B. So I'm going to multiply A by a negative 1. So we'll have negative 3x minus 2y minus z equals a negative 3. And then we just have x plus 3y plus z equals 4. And as you can see, we eliminated z, and we have negative 2x plus y equals 1. Maybe that should be minus 5y. I think this was supposed to be a negative 3y. And we'll hold on to that because we need to do the same thing and eliminate z as well. So we could use 2 times equation B to eliminate z and just use c. So we have 2x minus 6y plus 2z equals 8. And we'll just write down c. And as you can see, we've eliminated z again. And so we have negative 4x plus 2y equals 9. So we want to use both of these equations. Sometimes you could actually call them a different name. We could call this equation D and E. And let's go ahead and look at D and E. So if we have D and E and we want to eliminate a variable, we could go ahead and eliminate either one of them. So in D we can multiply by a -2, and let's see what happens. And we have 4x plus 10y equals -2, and we have a -4x plus 2y equals 9. I don't know if I wrote that same equation. I think this was supposed to be a -10y. Okay, so now when we add these together, we've eliminated x and y, and we have 0, equals 7, and this is false. So we have an inconsistent system, and there is no solution. And that concludes this video.